This is a lesson on multiplying a polynomial by a monomial. And in the first example, you're probably going to look at this and say, I've done this before, probably as early as pre-algebra. So what we have is -3, which is technically a monomial, and it's right in front of a parenthesis, so we're really multiplying by this parenthesis. So what we're going to do is we're going to distribute that -3 to each of the terms of this polynomial. So we're going to do -3 times 4x, and we're going to add -3 times 7. -3 needs some work. So when I multiply -3 times 4x, I get -12x, and when I multiply -3 by 7, I get -21, which changes the addition to subtraction. Done. That's it for example 1. Pretty straightforward, something that you probably already knew how to do. You just didn't realize that this was a monomial times a polynomial. Now, what happens when it's a little more complicated is that we're going to incorporate the rules that we've learned with monomials. So if I have 4x and I have to distribute it to 8x, 4x squared, and I have to distribute to 8x squared, 4x squared times 8x squared, and then I know I have a positive times a negative, so I know it's going to be minus 4x squared times 11x, and now we basically have two monomials to simplify. So we have 4 times 8, which is 32, and if I am multiplying the same base, recall that we have to add the exponents, so x to the second times x to the second would be x to the fourth. Second piece, 4 times 11 is 44, and we have x squared times x. Recall that that's just an x to the 1, and if I add those together, I get x to the third, and I'm done. That is multiplied. Example 3. Again, just distributing. Notice that my polynomial is just a little bit longer. It could be 100 terms. I'm not going to do that, but it could be. Here we have 3 terms. I'm going to multiply. -7 times 3 is -21. We have an x to the first times this x. Again, I'm multiplying the same base together. I add the exponents and I get 2. There's no y component there, so the y squared is just going to be y squared. Next piece, I'm distributing to the second component. I have -7 times +4, which is -28. I have an x to the first times x to the first, which again is x to the second. I have a y squared times a y, which is a y to the first, making it a y to the third. And then the last component, I do -7xy squared times a -9, and it's just coefficient times coefficient. Negative times negative is positive. 9 times 7 is 63. Keep the base and the exponents the same. So xy squared. And that one is done. And then we get to this last one, which is really a combination of the last assignment, the last video, and this video in one problem. So we're basically distributing here, we're distributing here, and then we're going to add those polynomials or the results of those multiplications. So let's give it a shot. Focus on this one first. 3x to the fourth y squared times 5x squared. 3 times 5 is 15. And that gives me 6x to the sixth. And then the y squared just drops down. Multiplying by the 2x. 3 times the 2 is 6. X becomes x to the fifth. Y stays y squared. And it's a positive times a positive, so it's positive. And then times the -3. 3 times -3 is -9. Keep the bases and the exponents the same. So that's the result of the first part. Moving to the second part before we look at common like terms rather. Let's see, let's go with orange. We have 6xy times 2x squared y gives us 12. 6 times the 2. X times x to the third is x to the fourth. Y times y. Again, y to the first times y to the first is y squared. Next piece. Negative 1x times the 6xy is going to be negative 6. X goes to 1 plus 1 is 2, and the y stays y to the first. Don't really need that 1. I'll leave it there for now. And then 6xy times negative 12 is negative 72. Keep the x, keep the y. So we're done our multiplication. If you understood that part, then you understand this lesson. And if you now understand what happens next, then you understand the previous lesson. So putting things together is important. Now I'm looking for the same variables. These are clearly different. These are all different. I'm seeing I have an x to the fourth y squared here, and I have an x to the fourth y squared here. So I am adding those two. Nothing else has a like term. Some are close, but they have to be exactly the same. X to the fourth y squared, x to the fourth y squared. They match up perfectly. Those are the only two that match up perfectly. 6 and 2, 5 and 2, 2 and 1, 1 and 1. So a couple of them are close, but not close enough. So let's combine these, and that gives me 3x to the fourth y squared, and everything else drops down. Notice that I just dropped that exponent of 1 because it's implied. And I've got 6x to the fifth y squared and 15x to the sixth y squared. One last note, you may have seen me just put a plus there. It's really important to just take a second and make sure that when I added these two pieces, that sign is appropriate. So I had a negative 9 plus 12. That is a positive 3. If it were a negative 3, this would be negative.